You guys are talking about this in this class, in the Dr. Lee class, congruences. So from the experimentalist point of view, definition is that A is congruent to B modulo M if and only if M divides A minus B. You know what the definition of divides means. So your next question should be, why would someone create this crazy definition when why don't they just work with M divided by A minus B instead? We write A is congruent to B mod A with the triple equal sign. Well, that's the reason we use congruences, because it's a way to take A and use equality. So that triple equal sign reminds you of equality. So it's some kind of way to talk about when two numbers are equal beyond just the numbers are equal. They're related to each other in some way. So that's my point, is that it looks awfully like an equal sign. And there's a reason for that. Remember that packaging idea that I showed you with evens and odds, that you take all the evens and put them in one box and put the 0 on the outside, and that represents the even box. And then you could take all the odds and put them in another box, and that represents the odd box, and you put a 1 on the outside as the representative. Let's go through that just a little bit more slowly, because it's a perfect example. So here's my package of the integers. Boxed up all the integers, I'm moving house. All the evens went into the even box, and I have a little label on it, evens, odds. But I'm going to put a picture of one item in the box to tell me what's in the box. 0 would represent the evens, and 1 would be the candidate for representing the odds. So that representation I showed you is all I need to talk about addition and multiplication. So I can add and subtract the entire boxes. Yellow's probably, no, it's bad on my screen, but it doesn't look as bad on yours. 0 plus 0 is really even plus even. Take two evens and add them, what do you get? Even. So 0 plus 0 is 0. 1 plus 1, 0, right? Because if you take an odd number and add an odd number, you get an even number, which is even. So I can literally add the boxes together. You can also multiply boxes. What's 1 times 1? 1 box times 1 box. Odd times odd. What would you get? Odd. So 1 times 1 is 1. Thank God, right? 1 plus 1 is 0. Sounds pretty good to me. What about 0 plus 1? Or 0 times 1? Even times odd. Even. So 0 times 1 is 0. So some of the properties of 0 are pulling through as well. You kind of twist your brain a little bit to think about it. This packaging or separation of the integers into these boxes is called a partition. I'm not sure if you heard about that in Dr. Lee's class, but you would have heard of that in modern algebra for sure. The idea of a partition, that you can take a big, huge set of items and package them up into disjoint sets. So what does that have to do with congruences? Well, let's just look mod 2. If I'm modding by 2, it means that A minus B is an even number for some S. For this to work out, A and B must both be even, or A and B must both be odd. There's no other way for that to work out. Think about that, right? So really, you're saying that all the things that are equal to each other are the things in one box. All the evens are equal to all the other evens. They're in the same box. So that partitioning is represented by the equality symbol in the congruence. Odds are also equal to other odds. 1 and 3 would be the same thing because they're in the same box. So 1 is congruent to 3 mod 2. Mod 2 because I have 2 boxes. Make sense? It's beautiful, actually. So A congruent to B mod 2 really means A and B belong to the same box. And they're really equal in some sense. You know, this is such a weird idea when you see it first in modern algebra, or probably in this class too. It's a weird idea. But you've been doing this all your life with, well, maybe not all your life. When do you learn fractions? Second grade's when you first learn fractions, but I think you learn equivalence of fractions 5th grade maybe. So almost all your life you've been talking about fractions. You know, you don't write 2/4. In fact, if you see 2/4, you're a math major, you probably freaked out and want to put 1/2 there right away, correct? That's because 1/2 is the representation of any other fraction that can be reduced to 1/2. The boxes are all fractions that reduce to a half, and 1/2 is the representative on the outside of the box. So you've been doing that for some time, to the point of it'll make you feel crazy to see 2/4 sitting there. In fact, I think I'm going to do that to you guys. I'm going to actually put things on the quizzes and exams that have unreduced fractions and see how much it bothers you. It will bother you.